Welcome to my project, Gina. It is the recession classification. So basically we were just trying to look for different economic indicators to try and classify a recession. This is definitely really useful to people who are in the financial industry. If you are holding stocks or bonds, this kind of information is tried modeled all the time. So this is kind of my go at it. I use leverage, the federal funds rate, inflation, stock market index, and a spread between debt sales. A lot of quantitative economic indicators. Everything was scaled quarterly, so it's all on the same timeline, and kind of made it a lot easier to check out on the graph. Here's just kind of a header pandas data frame of my data. As you can see here too, I did some graphs. The orange is what you can see is the recession dates, and then you can see in the corner here there's a couple more. There's the legend, but I had to scale it because during the financial crisis the leverage was so crazy that it just like throws off the whole scale of the graph. So scaled it down and then I scaled it back. So this is without the scale. And then, my exploratory data analysis, you can see some kind of trends happening. There's some undulations, before most of these recessions. So it looks good. And to kind of set a baseline, I used logistic classification at first. So we are, predicting the recession dates based on all of our other information. And as you can see, it did pretty good. There's some training error for sure, so it's not on target, but for a pretty basic classifier, Logistic does well. We have K nearest neighbors. So this one we definitely need to change our data types a little bit better, clean our data types up. What we're going to do here is just do a couple different K nearest neighbors just to show our success ratio. So when you do K equals 1 with 80 training, so there's 140 samples. So if we train on 80 of them, it gets a fairly good success ratio. Obviously, as you put the training numbers down, the success kind of changes a little bit. What I do next is I actually go through each iteration of K to 4, and then I use all the different training sample values to both train and test to see which gives us the best K nearest neighbors result. And then I plotted that, and when those show up, I'll kind of give more of a description there. But what I had did for my training model that we had not yet studied, I tried support vector machines. I looked it up a little bit, and it's a pretty widely used machine learning algorithm. I guess a lot of times it's used for unsupervised learning, and this is definitely a supervised learning task. Additionally, it is a non-probabilistic, so I guess you could also say it'd be non-parametric. So we're going to allow that to run, and now we have our K nearest neighbors, as we can see. So the K equals 1, this is just our different training sets. So it actually does very good. Given very little training data, it can predict like 81%, which is pretty amazing. And then K equals 1, it gets up there. 2, not too good. K equals 3 kind of peaks right over at 80%. K equals 4 has a good showing here too, kind of around 80%, and that's again with some pretty low trains. The support vector machines model had a very, very, very good test, I would say, because yeah, as you can see our confusion matrix, it tested very well, just only on 60 training data. So kind of did better than K nearest neighbors around there at 60 train. But one thing that I noticed was that the support vector machines model uses a little bit more time than k-nearest neighbors. So see up here, k-nearest neighbors is so 3.68 seconds there. Support vector machines 28.9. No, sorry. Here's 2.29. So in this case, that was a good one. It definitely does better than logistic classification. But k-nearest neighbors does better when k equals 1, given a pretty large training set. But yeah, overall, I would say that, for my classifiers work fairly well, I guess. I think I can use a lot more refinement into like, what, because I was doing more research into it, and I guess I could use some of what I'm looking at are what are called delayed indicators. But there are some different things I'd like to change around to make this more kind of complete. But for now, that's what I have for you. So thank you so much for tuning in, and I hope you enjoyed and learned something. Bye.